Let's talk a little bit about fractions. If we can make fractions be about something that you can relate to, they become a lot easier. Think about a fraction as a part out of a whole. So on this slide you see a green circle. Think of that as a green pizza. Everything can be solved with pizza and beer and money questions. If this pizza right now was to be given to you and you ate the whole thing, it's a Pomodoro pizza and it's delicious, you've eaten the entire thing. If that pizza was cut up, because Pomodoro pizzas are delicious, and you cut them, say, into nice, big, healthy portions. Now my lines are crappy, but let's pretend that I drew thirds. That pizza is now cut up into thirds. This is a third. The other one's a third, the other one's a third. Together, 1/3 plus 1/3 plus 1/3. Not to get too far ahead of ourselves, but a third plus a third plus a third is equal to 3/3, which is a whole. Now what if you had to feed more people, so you were more stingy, and you had to cut your pizza up into smaller pieces? If I took that same pizza that was originally cut into thirds and I had to subdivide it into sixes because there's more people. Now I'm going to have 6 pieces of pizza. If, however, I was lucky enough to grab 2 pieces out of the 6 now, very interesting situation arises. 2 out of 6 is the same size of pizza as 1 out of 3. And those are called equivalent fractions. When you look at pizza, that makes sense. The fraction on the left contains a number in the bottom that's not prime, 6. So if you divide both the numerator, which is the top, and the denominator, which is the bottom, by 2, you get a reduced fraction of a third. So a reduced fraction is the exact same quantity or size as the unreduced fraction, but it's written in a different way. 2 out of 6, if I wrote the top as a product of prime factors, that would be 2 times 1. The bottom will be 2 times 3. Because the top and the bottom both have a common factor, I could cancel those, say goodbye to the 2's, divide the top by 2, divide the bottom by 2, and I'm left with the reduced fraction of a third. So one of the ways to reduce fractions is to look for common factors. And by writing out a series of prime factors, it's easier to reduce. Consider the fraction 4 over 10. Small numbers, easy to work with. If in your mind you can break down the 4 into prime factors, you'll pretty quickly come to the fact that 4 is 2 times 2, and 10 is 2 times 5. So because we have a common factor, top and bottom, of 2, we can cancel one of those, divide top and bottom by 2, and we're left with what's remaining, which is 2/5. They are equivalent fractions, and 2/5 is reduced because nothing else goes into the top and the bottom. 48 over 120. These are the two composite numbers that we broke down in the previous video. So 48 was 6 times 8, or 3 times 16, or 12 times 4. Long story short, it was a series of factors. You can go back and look at the process, but it was 2 times 2 times 2 times 2, which is 16, times 3. They're all written out as prime factors. 120 was a similar breakdown. It was actually, say, 10 times 12, worked out to be 2 times 2 times 2 times 3 times 5. So how do we break this sucker down? Look for common factors. So I see a 2 and a 2, gone. A 2 and a 2, gone. A 2 and a 2, again, gone, and a 3 and a 3. What we're left with is a 2 in the numerator, 2 on the top, and 5 on the bottom. So, surprise, surprise, I chose 2 examples that both reduced to the same lowest terms. 2 over 5 is the lowest terms of 48 over 120. 2 over 5 is the lowest terms of 4 over 10. I also could have written it as 2 to the 4th times 3 on the top, and 2 to the 3rd times 3 times 5 on the bottom, and broken it down that way. So the 3's would go, and 3 of the 2's would go, and you'd be left with 1, 2 on the top. It depends on how your brain works. If you see it that way, you're left with 1, 2 on the top, and 1, 5 on the bottom. You always get to the same answer, but it depends on your perspective.